This video will give some examples of integration so that we can review the techniques that we've already learned. So looking at our first example, this isn't something we can just go ahead and integrate directly. What we can do is expand out the polynomial, so that would become x to the 6th minus 8x cubed plus 16 dx. And now that we have it in this form, we can just go ahead and integrate each of the parts individually using the power rule. So x to the 6th becomes x to the 7th, and then we have to divide by our new power. Similarly, x to the 3rd becomes x to the 4th, and we're going to have to divide by 4. And then our last term is just 16x. So we have to add in the plus c, of course. And this just simplifies to 1/7 x to the 7th minus 2x to the 4th plus 16x plus c. Our next example is a little bit complicated. So we can divide this up into two integrals. We'll take the first term first, and then we'll integrate the second term later. So looking at our first term, what we can do is use substitution. We'll let u equal ln x. Then what we have is du equals 1 over x. So then the integral of 3 over x ln x becomes the integral of 3u du, which is easy enough to solve using the power rule. We know that that's just 3 over 2 u squared. And so now we can go ahead and plug ln x back in for u, giving us 3 over 2 ln of x squared. And for the sine squared portion of our integral, we can use a trigonometric identity. Replace sine x squared with 1 minus cosine 2x over 2. And so now we have the integral of 1/2 minus 1/2 cosine 2x dx, which becomes 1/2 x minus 1/4 sine 2x. Note that we have a 1/4 right here because when you take the derivative of sine 2x, you have to multiply the answer by a 2 from the chain rule. So now that we have these two answers, our final integral is just the sum of these. So our final answer is 3/2 ln x squared plus 1/2 x minus 1/4 sine 2x, and of course plus c. Now in this example, this is just to remind us that when you have the integral of e to the x dx, you just end up with e to the x again plus c. And so similarly, if you have the integral of e to the negative x dx, then you just add a negative sign in front and another plus c. So our answer for this is just e to the x minus e to the negative x plus c. Alright, so the last few examples are just going to be some review of our integrals for trig. So if we recall, the integral of 1 over the square root of 1 minus x squared dx is equal to inverse sine of x plus c. So if we have that multiplied by 2, then our answer is just going to be 2 inverse sine of x plus c. The integral of 1 over 1 plus x squared, this is just something you have to memorize. It is inverse tangent of x. last one's a bit more complicated. First, we're going to start just by distributing out the multiplication. So we have tangent x plus tangent x secant x dx. Now we can rewrite these two functions in terms of sine and cosine. So that gives us sine x over cosine x plus sine x over cosine x times 1 over cosine x dx. At this point, we can use u substitution and let u equal cosine x. So du equals negative sine x dx, meaning we can replace our integral with the integral of minus du over u plus minus du over u squared, or the integral of 1 over u minus u to the negative 2 du, which is the ln of the absolute value of u, and then the second part you want to use the power rule. That becomes plus u to the negative 1. And so now we can just put it back in terms of x, and we end up with the ln of the absolute value of cosine x plus 1 over cosine x, or secant x.